How cool is that, huh? It's like our pet. It's fearless. Doesn't mind us, doesn't mind the dog or the cat or any other animals. Nothing. Yeah, it's now sunbathing there on the bench. Because we had a big thunderstorm last night, lots of rain and everything. And they like the sun. They're sitting in pure sun. Sometimes here on the gravel. They don't mind 50 plus degrees. It is incredible. And we've got several of them across the yard. All have their own territory. And sometimes they are chasing each other through the garden. Okay, we are expecting another 40 degrees today, maybe even 41. Welcome back to the off-grid garage here in super sunny and hot Australia. It is extremely hot at the moment. But as I teased already in the last video, we now have aircon inside the battery and system room here, and it is incredible. It is amazing. We've got this running now for 3 days, 4 days, 3 days, I think. And we had an extremely hot day yesterday already. So I could see what the performance of this aircon is and what it does to the batteries. And because everything is connected to Home Assistant, we can have a look at the curves and explore together how hot or how cool the equipment now stays. Yeah, in the last couple of days I have finalized the insulation here in the garage, except of the roof panel here. But I have closed all these gaps here between the metal beam and the roof. Also the side gap there to my workbench. This is all insulated now, double insulated. So it's like 80 millimeters of insulation. You can see it from the outside. All nice and insulated. And here in this area, here in this mush area with all the cables, I've put little bits and pieces in these gaps from here and from the inside of the room. So this is all now closed up. There are no lizards and spiders getting in anymore. We are good so far. But we still have the gap around the roller doors, which is like, that'll be next on my list. But I also have this gap up there. And this is the top of the roof. And there's no solar panels on top of it, so this area gets really, really hot. So I want to put some foam insulation in there as well. And then I cut off some stripes of this foil board and put this in, so it is closed basically with the same material as over here. Got heaps of this foil board left. Then I'll just squeeze it in there between the plasterboard wall and this rafter. And it will close the whole gap to the top of this hot roof. Yeah, and at the moment I've got the air conditioner sitting on dry because we had this thunderstorm last night and the humidity in here was like 70–80% this morning. So I turned on the air conditioner and set it to dry. So if the temperature rises inside this room, this dry mode does not cool down your room. It just gets cold enough to suck up the water from the air, and the compressor on the outside runs on minimum power and frequency. So this is the lowest level basically. Also the fan speed is set to silent, so this is the slowest speed. So it just gets a bit of airflow through the head unit and sucks up all the water from the air. I can still feel nice and cool air coming out, but it is not holding the temperature because there's nothing to set. Yeah, it was a bit of drama with the air condition installation because I booked it in long time before Christmas and they already told me on the phone they haven't got time anymore this year, so it was last year, because everyone wants to get shit done and they were completely booked out. So they booked me in for the 5th of January and the technician actually rocked up on that day and they started installing at the outside unit, put the pipes in, connected everything, pulled the cables in for the head unit and also the main cable to the distribution box there. But then he discovered a problem with one of the pipes, the bigger one, which carries the gas. So from the factory, this head unit here comes with all the pipes and drain hoses and everything tucked away underneath, pointing this direction. And to get these soft copper pipes in any other direction, you're not bending them straight and then into the other direction, what we tried. You leave them in this direction and twist them in the direction either going through the wall straight away or facing this way like we have done here. So I took the head unit back to the company where I bought it and the boss there showed me how to do it correctly. There you go, learn something. Twist, not bend. You basically only bend the pipes if they need to come straight down. You learn something new every day. Yeah, and the outside unit sits on these concrete blocks we have put in. We've got the isolator here, and this is where the pipes and the drain and the cables come through. Just a normal AC installation, you know, nothing too spectacular. The only thing I changed was this drain pipe. It dripped too close to the timber and this area was wet all the time. I'm trying out different positions at the moment, that's why it is so long. I had it further to the concrete block, but then it drips through the gravel into the concrete foundation, and then the moisture starts rising into the concrete block and it was all wet here. I didn't like this situation either. So I bent it a bit this way now, just a bit away from the concrete. Now it drips through the gravel and goes into the drainage pipe, the French drain underneath here. And you can already see how much water there's actually dripping out just on the dry mode. So this needs to be adjusted as we go and experiment a little bit with it and see how we go. I also covered all these holes here with foam, the same over here, so no larger insects can go in. There's obviously a bit of a gap here and there where ants probably could get in, but I need to monitor the situation. I also put some split loom around these refrigerant pipes. They're all insulated, but this one gives them an additional UV protection. Yeah, so at the later stage I want to build a little bit of a roof above this unit here. And it would be better if the isolator is on this side here. But I was too late and the electrician already installed it on this side. It doesn't matter. I extend the roof a little bit so the isolator is under the roof as well. And the plan is to have this roof somehow on a hinge, so I can actually lift it up and clean everything behind it, clean the air conditioning unit, and then put it back down. So it gives the aircon a bit of shading. You can see the sun over here already, and this line will slowly creeping down now as the sun comes around. Where is it? Over there. Sun goes around over here, and then we have full sun in this alleyway until about 11 o'clock, and then we get shading from this roof again. But I really want to have this air condition under a roof a bit. So for now I take this insulation from one of the batteries here and put it on top, and so it gives the unit a bit of shading. Doesn't need to be in the sun, right? Because it's so hot. And because we have installed the Wi-Fi connector in the aircon unit, it connects to an app which is called Remote Mobile Controller. This is for the Daikin air conditions which have Wi-Fi connection, and it gives you access to all the air conditioned units inside your home. So here we can see the battery room is actually turned on. Yeah, it sits on dry mode, and as you can see there's no way to select or to adjust a temperature. And if we switch this now to cooling, we can then actually set a temperature. Yeah, 23. We probably put this up to 25 degrees. So if it keeps close to 25 degrees inside this battery room, I am super happy with that. But here again, I need to get a bit more experience with the system and what temperature to set to keep the batteries and the inverters cool. But of course, as soon as the air condition is on the Wi-Fi, Home Assistant picks it up. And you can see it here. It provides 11 entities. The battery room sits on cooling at the moment. Power is on, so I can remotely control the air condition with Home Assistant as well as with the app. It gives us the compressor energy consumption, the estimated power consumption at the moment, the frequency the compressor is driven with. I don't think this one works actually. It shows always 0, but this is the overall energy consumption for cooling and heating. But I'm using this one up here, that's fine. And the inside and outside temperature. So the frequency can go from 12 Hertz, which is the minimum before it turns off, all the way up to 72 Hertz. And this is then the maximum power the outside compressor can deliver. While 72 Hertz is already a bit of overdrive, so this is really stretching it out, maximum power. I think it is called boost mode or something, but this is also when I can see 1 kilowatt of power the whole unit takes. Well, this is one of the most efficient aircons out there. It has a COP of 5.1, whatever it says here. So really energy efficient. But boost mode is about delivering as much cold air as possible. Yeah, and the efficiency goes overboard. And I've just built this little tiny line in my dashboard here. It shows me the AC, so the air-conditioned battery room. It sits on cooling at the moment, which is also reflected in a blue symbol. If it sits on dry, it is a yellow or an amber symbol. And if it is off, it is gray. Also, this button here changes. When the air conditioner is turned on, it's green, otherwise it's red. So we've got 23.5 degrees inside the battery room at the moment. It's nice, right? And 68.7% humidity, yeah? We're using 290 watts. Compressor runs on 12 Hertz, and we have used 0.3 kilowatt hours since midnight. And when I click on it, it gives me more details about all the air conditions inside the house. And I can also click on certain entities here and it gives me the curve. So we can see the power consumption for the last 24 hours. All right, let's collect some data over the day and I'll show you later what the effect is of the air condition to the inverters and to the batteries, and mainly for my own well-being. Because now it is so nice when I'm out in the garden and it is hot or something, I just come into the garage and check the phone for a couple of minutes, cooling down, and then you go back out. But as yesterday, it can be very brutal. You've got like 38, 39, 40 degrees outside of this room and inside is 25, 26, and the air is dry, and out here it is humid as hell. Okay, before I let you go, it is now 9:15 and let's check on the battery and other temperatures. So we've got 26.5 degrees inside the battery shelf, which is perfect. We've got 24 degrees in one of the other batteries, the Powerball, the additional batteries. Temperature garage, this is inside the battery and system room, 23.6 degrees, and outside in front of the garage, 30 degrees Celsius already. Wow. Okay, these are all the temperatures I have. I think I've got another thermometer somewhere here. I'll install another thermometer here at the workbench to see what the temperatures are like outside of the cooling room, but I cannot really show you what difference it is when we walk out from the cooling room into the garage back. It is like, whoa, that is hot. That is the roof metal, no insulation. And we have like 72 degrees on the metal. Wow, 60 over here, and this is directly the roof metal, about 70 degrees, full sun. And of course you can feel this heat radiating down here on the air conditioned unit, and it sucks in this hot air, and that is not great. And that's why I want to put in this insulation like this, and then the foil board basically underneath here with a bit of air gap in between. And this already makes a huge difference. When I hold my hand here, I can feel the heat, and it's pretty much gone here. And I'm also keen to see how long this foam will last. What do we get here? 37 only. So it's almost half the temperature only as without this foam. Wow, that makes a huge difference already. Yeah, this beam is still hot, yeah? Because it's like an S shape and it's connected directly to the roof panels. So this one will always stay hot. It's just what it is. So here in this top area, I put some double insulation under the roof, 40-50 millimeter foam. And then additionally, we use the foil board as well. Because in this area, there are no solar panels, and this is the plank metal roof. 71 degrees we have measured, right? Here it is fine. Solar panels on top. Yeah, no heat radiating. But especially here where the air condition sits, why not have this double insulation? Alright, I used the 3D printed clips again and it works a treat. Look at this, double insulated. You can barely feel any heat. Pretty good. Yeah, here, it's almost cold. That may rather come from here though. So there's the final product. We've got double insulation here, the foam underneath, direct under the roof. Now there's a bit of space actually, then comes the foam, then there's another space, and then there's the foil board. See, it fits perfectly into this gap up there, and it keeps the optic. And I think the aircon doesn't need to work as hard anymore. Yeah, I still need this cover there to hide the hoses and the cables and everything. We've got the insulation panels here. I haven't done anything here in this section because I'm not sure how to proceed here with all the cables and all this stuff happening up there. I cannot go on top of this metal beam, you know, this is all full of cable ducts now. So I have to come up with another idea where to stop with the insulation. A 3D printed solution might be possible here. I'm not sure yet. Anyway, this is all nice and beautiful. We've got double insulation up there above the air condition now. There's no heat radiating through anymore, which is beautiful. And now we have to, and now here comes the hard part. We have to leave the battery and system room and have to go outside to the workbench. Because you want to check on the temperatures. It'll be hot out there. Jeez, better hurry up before I sweat everything through. Okay, it is now exactly 12 p.m. So we are at 97.3% state of charge for all the batteries, 98 in the auxiliary batteries, Powerwall, and 94 in the battery shelf. So we are getting 12.2 kilowatts from solar and 8.7 goes into the batteries. 111 amps into the additional batteries. Well, we don't have the 50 amp breaker restriction anymore. Last week I have removed the 63 amp breaker and replaced it with 2 pieces of copper. Because all the battery strings coming from the Lynx bus bar, they've got 100 and 150 amp fuses in there. And we've got this all connected with 35mm cables. So I can actually go 100, 120, 130 amps here. So anyway, this is a topic for a different video. I want to have a look at the temperatures. Look at this battery shelf, 29.9, yeah? We had like 100 amps going into the battery shelf for quite a while to charge it up. And look at the temperature here. It was 26 in the morning and now we've got 29 or 30 degrees. So 4 degrees more than this morning. That is nothing. Yeah, looking at the temperatures from last week, you can probably tell when we installed the air conditioner, right? And afterwards the battery temperature didn't go as high anymore. So we had like 31 degrees on Saturday and 31 degrees yesterday, and today we've got 30 degrees. So the day before the aircon we had 36 degrees in the battery. Here we had a bit of cloud situation, so the charging current was not as high, but still reached 32 degrees. Here 34 degrees and so on. So quite a difference for the battery shelf. So and here you can see the temperature inside the battery and system room, yeah. Before the air condition installation we had 32 here, 34, 34. Then we installed the aircon and I turned it on at exactly this point of time and the temperature went down in the middle of the day. And since then, moderate temperatures, low 20s during the night and 26 yesterday, 26 on Saturday. Yesterday with 40 degrees outside we have 27 degrees, 27.6 degrees only. That is incredible. Definitely it makes a huge difference to the battery and system room and all the equipment inside, of course. Battery has just reached 30 degrees, but charging tapers off now. We are already at 54.9 volts, so there's not much going on until 55.2 and then we are throttling down and there will be no current. We're going into float mode and the current will basically die off and then temperature will only go down from here. But look at this here, the air-conditioned battery room. Yes, it's still on cooling, 26.7 inside, 60.7% humidity inside the battery room, so it has come down from over 80% this morning. But the system takes 950 watts electrical power now, yeah, and it is running on 72 Hertz, so it is already in boost mode again. Let's have a look at the frequency here. Yeah, tonight I had the air condition off because we had this thunderstorm last night and it was like 20 degrees outside, nice and beautiful. But then this morning I turned it on to dry and then frequency went up and up. So we are now sitting on boost mode. This is the maximum load on the system, basically 950 watts. And of course the efficiency of the air conditioned system goes down in these conditions then. Yeah, I found the specifications of the Daikin Cora 2.5 kilowatt air conditioned system we have put in here. And here the cooling capacity is 2.5 kilowatt rated, but it can modulate between 0.9 kilowatt cooling up to 3.7 kilowatt cooling. And this is exactly what we see right now, boost mode. Yeah, and the EER, the efficiency factor, is usually 5.1 for this aircon. Yeah, but at the moment we are producing 3.7 kilowatt of cooling power and we are using 1 kilowatt of electrical power. So this gives you a EER of about 3.7 only. But this is only in these extreme weather conditions when we have 40 degrees plus or so. then the air conditioner needs to work hard. But yeah, it keeps the temperature inside the room absolutely nice and beautiful. So the question is, how much energy does this air conditioner use per day? So first day when we turned it on, it went straight to 8.3 kilowatt hours. Yeah, this is because the room was already heated up from the days before, obviously without the aircon, and it took a lot of energy to cool it all down, to cool the masses down, the batteries inside and all the metal and everything, the concrete floor, everything need to cool down. So 8.3 kilowatt hours for not even a full day. Second day, when the battery room was already cooled down, we have used 3.8 kilowatt hours only. Wow, half of it. Yeah, Saturday it was 5.3, and yesterday it was, what does it say, 8.6 again. But yesterday 40 degrees as today. Yeah, but this is all excess power I have left over anyway. I wouldn't use this power for anything else, and the solar system would throttle down anyway, and this power and energy would be lost. So here I use it for the aircon to cool down all the batteries and the equipment and myself. Let's have a look at our water supply here. Oh, this is almost running. So much water coming out of this air condition. Wow, that is a lot. And this is the noise it makes outside on boost mode. 3.7 kilowatt cooling power, 1 kilowatt electrical power. Can hardly hear it. Pretty nice system. That's probably like 50 degrees here. Oh my god. Back in the cooling room. So nice. Unbelievable. What a difference. So when we have a look at the inverter, 31 degrees on the outside. I can hardly, it's actually cold. It feels cold. This metal feels cold. This one is off anyway. Here, the Powerball. 27. Our 250 amp breaker, which was always a bit hot in these conditions, 28.4 degrees only. Wow. Yeah, solar charge controllers, they were actually throttling down before that because they got so hot. They ramped the solar production down. But now we've got beautiful 43 degrees, that's the maximum, and this is a 4 kilowatt MPPT. Nothing against the 65 or 70 degrees we had before. Anderson connector, 46, 47 degrees, yeah. This is 112 amps going through it now, and this is rated for 120 amps. Yeah, this cable here, the negative cable, gets a bit warm. Maybe I have to recrimp this connector here. Maybe the crimp is not good. Yeah, this one gets warm, but this one gets a bit hot here. Everything else, 25 degrees here. It is just nice and beautiful. There we go, 122 amps into all these batteries here at the moment. But we have 54.5 volts or so they will all start absorbing and balancing very soon. We've got 39.6 degrees Celsius outside the garage and 33.9 inside the garage here at the workbench and 26.7 inside the cooling room. Yeah, battery temperature has not risen anymore, 30.0 degrees. 116 amps going into the Powerball at the moment. Everything seems to be good. Okay, my friends, this was just the quick update about the air conditioned situation here in the battery and system room of the off-grid garage. Everything is installed now for 3 or 4 days or so. And you can see actually the temperatures as well in the Victron VRM. I'll link this down below again. So you can actually display the long-term temperature of the inside here of the battery and system room. And you can definitely spot the point where we turned on the air condition for the very first time. Yeah, and the more insulation I go in, the less harder this air condition has to work in these conditions then. Next step will be to put this brush seal at this roller door from the outside, and then I use some foam and seal this all up from the inside as well. But before that I have to open the roller door one more time and find these holes left and right, right and left, where the roller door actually locks into the rail. So I need these two positions to lock the gate so nobody can open it from the outside anymore. Yeah, and then we can seal off the top here and then everything is good. Except of this stuff here. This will be a challenge. I'm not going to lie. As always guys, thank you for watching. Thanks for all your amazing support. More videos are on the way. If you want, leave a nice comment, drop me a like. If you are new here, subscribe. And until the next video, guys, you stay charged, stay safe, and thanks again for watching. See you then. Bye bye. So nice working in here today. Beautiful.